Hi, and welcome to the video on accuracy and precision. These are your accuracy and precision notes. So we've already discussed accuracy and precision in a target, and we said that we can tell from a target or bullseye that we have high accuracy when the darts hit at or near the center of the bullseye. So in this first example, these dots are all at the center, so we know that that's high accuracy. In the second example, which is probably not the best example, the dots are near the center, and so we also say this is high or high-ish accuracy. On the other hand, the third one, the dots are very far away from the bullseye, so this is low accuracy because they're far away. And the same thing with this last one. Most of them are far away from the bullseye, so we say low accuracy. Precision, on the other hand, describes when the dots are in the same position, they're consistent, or they're near each other. So here we have high precision because all of the dots are near each other. The third one also has high precision because all of the dots are near each other as well. Whereas the second and fourth one, the dots are spread out, so they're both low precision. But what about in data? Accuracy describes data that is correct or close to the true or actual value. And the way that we evaluate accuracy is the first thing we need to do is calculate the average if you have more than one trial. Then you're going to compare the average to the true or actual value. If the average and the true or actual value are similar, the accuracy is high. Precision, on the other hand, describes data that is consistent or all the trials are the same, similar to how all the dots were together. The way that we evaluate precision is we compare the trials, and if the data in the trials are similar or consistent, the precision is high. Now, if you need to, feel free to pause the video so you can copy these notes in your handout. And now we're going to look at some sentence frames that we could use when we're explaining accuracy and precision. So here are some sentence frames we're going to use, and then afterwards we'll use these sentence frames to help us with these examples at the bottom. These are optional sentence frames. You don't need to use them, but they may be helpful. So let's say, for example, you're given some data and you want to explain how you know whether or not the precision is high or low. Like, how do you know that? So you can say, I know, and then you can put the student's name, whose data it is. You can say their data is high or low, their data has high or low precision because the trials are either consistent or not consistent. Similarly, you can use these sentence frames for accuracy. You can say you know that whoever the student is, data has high or low accuracy because their average is close or not close to the actual value. So let's take a look at how we would use that with these examples here. Below the data, Christopher and Ashley collected while measuring the mass of a marble. The actual mass of the marble is 5.5 grams. That's key information, so I'm going to go ahead and underline that because this is my actual mass. Evaluate the accuracy and precision of the data and explain your answer. Okay, so let's start off with precision. We'll do that one first. So for precision, remember, we're going to compare the trials. I don't need to calculate average yet. All I have to do is compare the trials, and if they're similar or consistent, the precision is high. So if I look at Christopher's trials, trial 1 he has 7.7 grams, trial 2 8.1, trial 3 8.0, and trial 4 7.9. All of these numbers are pretty consistent, right? They're near each other. And one way we can visualize it is if I were to show this on a number line, Christopher's data on a number line, you can clearly see that all of his data is kind of clustered together. So that's high precision. So I can say, I know Christopher's data has high precision because, well, this B/C is because the trials are consistent. Okay, so all of these trials are consistent numbers or similar numbers. Now let's look at Ashley's precision. If you look at Ashley, she's 3.9 for trial 1, 8.2 for trial 2, and 5.0 for trial 3. So what do you think about these numbers? Are these consistent? No, they're not. So what does that tell you about the precision? Is it high or low? That's right. Ashley's precision is low. So I can say, I know Ashley's precision, or Ashley's data, I should say, I keep doing that. Ashley's data has low precision because the trials are not consistent. And again, I can visualize that on a number line. So if we look at Ashley's data on a number line, you can see her values are all spread out. All right, if you need to pause the video to copy this information down, go ahead. And then we're going to move on to average. All right, so let's take a look at the average here. And to calculate the for accuracy, and in order to determine the accuracy, we actually need to calculate the average. So I'm going to move this up. All right, so remember, to calculate the average, I'll do that in blue. What we do is we add up the trials and then divide by the number of trials. So we'll do Chris's average. For Chris is 7.7 plus 8.1 plus 8.0 plus 7.9. So I'm going to add all that together and then divide by 4 because there's 4 trials. So Chris's average when I add all of these numbers together, I get 31.7, and then I can't forget to divide by 4, and I get my average to be, or his average to be, 7.9. So the average is 7.9. Now, is that accurate? How do I know? Well, remember, I calculated the average so I can compare it to the actual value. The actual value was 5.5, but Chris has an average of 7.9. So what does that say? That says that his accuracy is low. So I can say I know Chris's data has low accuracy because his average is not close to the true value. Okay, so remember the true value here is 5.5 and Chris's average is not close to that. All right, let's look at Ashley's. So again, I'm going to calculate the average first. I'll calculate Ashley's average in red so we can keep track of it. So for her average, we'll do 3.9 plus 8.2 plus 5.0. And I'm going to divide this time by 3 since there are 3 trials. When I add these all together, I get 17.1, and then I can't forget to divide it by 3. And I get Ashley's average to be 5.7. Okay, and let me not forget the units, that's grams, and I'll put the units over here for Chris as well. Okay, so if I compare Ashley's average, 5.7, to the actual value, what do you see? They're very similar. So what does that tell you about Ashley's accuracy? So, yep, Ashley has high accuracy. So I can say, no, Ashley's data has high accuracy because her average is close to the true value. Okay. All right, so I hope you found this video helpful. So remember, for high precision, we have consistent trials. With low precision, the trials are not consistent. For high accuracy, the average is close to the true value. And when it's low accuracy, the average is not close to the true value. All right, I hope you found this video helpful. Have a quality day.